Hello everybody. So today is problem set 86 and we are going to be covering number families, okay? So on the board I have listed your homework as geometries number 10, 13, 19, and 20. You do not have to do those. For today we're going to begin with a review of the number families that we've already learned. The first one is called the counting numbers, and we've already talked about the counting numbers quite a bit. When I ask you to list a set of numbers, I'm asking you to list them this way. You use a braces with the ellipses. So the counting numbers are when I say count, like say count to 10. Usually you begin with the number 1, 2, 3, and then dot, dot, dot. So these are called ellipses and these are braces. So the set of counting numbers would be written as 1, 2, 3, dot, dot, dot. You then have the set of numbers called, and by the way, counting numbers are synonyms with natural numbers. Those are the same. So remember, the natural way to count is 1, 2, 3. Then we have the set of whole numbers. Remember I told you in the beginning of the year, think of the whole. Think of your finger, the whole, which is 0. So you add a 0 and you go 1, 2, 3, dot, dot, dot. Again, listed with the braces and the ellipses. The dot, dot, dot means they continue indefinitely, okay? Then we have a set of numbers called the integers. And remember that an integer is any number, any counting number, and its opposite. Well, since 0 doesn't have an opposite, we say the counting numbers, their opposites, and 0. So you would start with ellipses, meaning it's going to continue, and then -1, 0, 1, dot, 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 and then there's the ellipses. So you can see just by looking at these numbers that all of my whole numbers, except for 0, are counting numbers. So I could say all of my counting numbers are whole numbers. All of my whole numbers are integers. But you cannot say all of my integers are whole numbers, because only some of your integers are whole numbers, only the number 0 and going on. And you can only say that some of your whole numbers are counting numbers, because 0 is not a counting number. So you have to be careful how you read that. Then there's a couple of other set of numbers that are going to be new to you, okay? The first set of numbers, if you're looking on page 525, that's what we call a Venn diagram. A Venn diagram allows you to compare different relationships between a set of things, okay? So in my diagram here, you have counting in the middle, whole numbers, integers, and then the last set of numbers we're going to learn about today is called the rational numbers. Rational numbers, okay? Now, rational numbers include, think of the root word ratio, okay? A ratio is, remember, a comparison of two things, like 1 to 2 or 3 to 5, okay? So a ratio is a rational number, is any number that can be written as a fraction. Now let's go back. Can you write 1 as a fraction? Well, of course you can. You would write it 1 over 1. How about 2? You would write it 2 over 1. And we would keep going on and on. So that means all of my counting numbers are ratio numbers. How about whole numbers? Can you write 0 over 1? Yeah, 0 over 1 equals 0. So yes. So that means all of my whole numbers are also rational numbers. How about your integers? Can you write -1 over 1? Yes, -1 over 1 equals -1. -2 over 1 is -2. So any number that can be placed over 1 and be simplified is considered a rational number. So that means numbers that cannot be written over 1 would be irrational numbers, and that's for a different lesson. But a good example would be pi. Now we learned that pi equals 3.14, but remember that actually it doesn't equal it, it's about 3.14, because remember, if we take 22 over 7 and we divide it, remember that these are about equal. We're going to say 21, 1, 0, 1, put the dot here. It's going to be 7, 3, 0. That's going to be 4, 28, 0, 2, 14, 6, 0, and you're going to see this is actually going to keep going for quite some time. It actually continues to go. So that means that 22 over 7 is not exactly equal to 3.14. They're about equal, but not exactly equal. Therefore, it's not a rational number. It doesn't have a repeating, it doesn't terminate at some, it does, but it takes quite some time. It just continues to repeat itself, okay? So rational numbers, again, are numbers that can be written over 1. If you look at the bottom of page 524, we have some examples. 1 over 2, 5 over 3. 5 over 3 can be made into 1 and 2/3. Negative 3 over 2 can be 1 and negative 1 and 1/2, and so forth. So we can see that those will continue. Those are all called rational numbers. If you look on page 525, we have other examples. It says that sometimes rational numbers are written in decimal form. Okay, so consider this number 1/2. In a decimal form, it would be 0.5, or this one would be 0.6. Now we might look and think it can't be written over 1 because you can't put 0.5 over 1. That's true, but I can make 0.5 a fraction. So anything that can be written over as a fraction is a rational number. It doesn't have to be over 1, it's any fraction. So yes, this is a rational number. So decimals are rational numbers. It says, okay, in which case the decimal, now 0.83 with a bar can be written as 5 over 6. Now it does repeat itself. It's about 5 over 6, but it would be considered rational, okay? Let's see. Now, why is that important to the lesson? Aside from knowing what the different number families are, so you are now going to be writing the set of, you're going to be graphing certain specific number families. Before, I would say graph x is greater than or equal to 1, and you would say, there's my origin, there's my 1, and guys, again, you're still writing the numbers above the number line. They need to be written below the number line, okay? Number lines don't have numbers on top. Okay, so we have 0, 1, 2, and 3, and we're going to graph 1, and it's underlined, so it equals 1 greater than 1. So we're saying any value that is greater or equal to 1. So 1 is greater or equal to 1, and everything to the right is also greater than 1. So we move to the right. That's how you write a specific value. But on example number 1, it says to graph the integers that are less than 4. So integers less than 4. So I would advise you to start by writing the equation, integers less than 4. Then graph the equation. So you would say, okay, let's start by writing an origin, and let's graph the 4. Okay. Now, less than 4 means they're going to go to the right. Now, if I wrote a number line going to the left with an open circle, it looks like I did it right. But you will see you did not, because what is the definition of an integer? It can only be a negative or a 0 or a positive. But if I put a solid line, I'm saying that all the numbers in between, including 1.1, 1.2, 1.5, 2.2, are also included, which is not true. So instead, what I want to do is I want to say 3, 2, 1, negative 1, negative 2. Then I'll draw an arrow because it means it continues. Notice there's not an arrow on the right. And then this time, instead of drawing a solid arrow, I'm going to say the number's less than 4. Well, 4 is not less than 4. So I'll put a dot here, 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 and here. I don't want to keep going forever because that would be a lot of numbers. The arrow on the left indicates that I'm continuing on, but I can just list a couple of the negatives and a couple of the positives, and it would be so forth. Now again, I did not put a dot on the 4 because it does not include the 4. Okay? If your graph says if your value says to graph the whole numbers, so let's say whole numbers greater or equal to 2, then you would do this. Graph the 0, graph the 2. The numbers greater than 2 would be 3, 4, and so on. So there's the arrow indicating so on. On the 2, I would say, okay, I want to include it. This means equal. So this reads whole numbers greater than or equal to 2. Well, there's my whole numbers. The first whole number is 0, but 0 is not greater than 2. Then there's a 1, but 1 is not greater than 2. There's a 2. 2 is not greater than 2, but 2 does equal 2, so this time I need a dot. And then 3 is greater than 2, 4 is greater than 2, and then the arrow indicates it goes on and on and on. So that is how you would graph a specific set of values for a specific number. Let's see. That is it for our lesson. It's fairly simple. You just have to know the different number families and how to graph them. Please let me know if you have any questions.